Hello everyone, I'm Sanket Singh and welcome back to my channel. So guys, recently as you know that we have launched our brand new system design course where we are going to talk about end-to-end high-level design, low-level design and a lot of cloud technology, which is going to be an end-to-end hands-on course as well. Now in this particular video, as requested by a lot of you guys, we are actually posting a course preview so that you can get an understanding that how exactly the course is going to be, how exactly the content delivery is going to look like. This is one of the most interesting lectures that I recently took around single responsibility principle. Single responsibility principle is one of the most important solid principles that you have to know if you want to get a good understanding of low level design and design patterns. So here's the lecture for you. Enjoy that. And if you want to enroll for the system design course, do check out the link in the description section below and use this coupon code so that you can get maximum discount possible. This course is going to have a lot of live classes where we are going to talk about a lot of different systems, high-level design, and apart from that, also code a lot of low-level design problems. It's going to be a one-stop solution for you in case you are going to prepare for your interviews in high-level design and low-level design. That being said, without any further delay, let's just start. So before moving forward, I would like to discuss about a brand new offering that we have at Algocamp. So if you are somebody who already knows software development and are very much intrigued by the crazy amount of stuff that you can actually develop using the knowledge of your software development, then this is going to be something interesting for you. So if you're somebody who loves to take deeper dive into everything and wants to understand that how exactly scalable systems are developed, not just on the high level part, but on the low level coding implementation part as well, then we have actually launched our brand new system design course, which includes both the low-level design aspect and the high-level design aspect of the scalable systems. In this particular course, with respect to HLD, we are going to talk about a lot of systems, including system design of things like Uber, streaming systems like Netflix, how you can actually design your own ad-click aggregator, how you can design scalable notifications, how you can design code deployment systems, and many more. There are tons and tons of high-level design problems that we have added. Apart from that, there are a lot of interesting system design concepts that we have actually added, including design patterns like saga pattern, anti-corruption layer pattern. We have also added orchestration pattern and some other interesting aspects around caching layer, blob storages and whatnot. This is going to be a power-packed course for high-level design, and along with that there is low-level design as well, where we are going to talk about solid principle, we are going to talk about tons and tons of different design patterns, and we are going to solve a lot of problems, including designing your own logger, designing kind of like a chess game, designing kind of like a book my show system, a splitwise and whatnot. This low-level design part is going to technically prepare you for any kind of a low-level design or object-oriented interview, as well as for your machine coding interviews as well. This is going to be definitely a power-packed live course where we are going to talk about everything end-to-end in system design, and we have also added some additional topics around concurrency and testing as well. So what are you waiting for? All the details about this particular course is actually mentioned in the description section below. Go there, check it out, and use this particular coupon code to actually get the maximum possible discount, and see you guys in the course. That being said, let's go back to the video. So what we are going to study today is we are going to talk about software design principles, right? So whenever you actually write any piece of software, doesn't matter if that piece of software is a front-end code, it's a back-end code, right? A bunch of scripts, whatever you write, even when you are actually designing a bunch of databases and everything, right? The thing is that in every aspect of software development, there are some certain set of principles, recommendations that exist, right? And if you try to follow them, then your overall code quality increases. Overall code quality increases, right? This whole module is going to focus, like the final agenda of this module is not about how much projects you made or not about what new technology you learned. The final agenda of this module should be how much improvement you have in your code quality, whether your code quality overall increased or not. And if not, if let's say your code quality doesn't increase with a high delta, are you able to at least smell bad code, right? Because whatever principles we are going to see, they are going to first of all point out that this is a problematic situation, that is a problematic situation. Okay, and once done, once that thing is actually pointed out, then we are going to actually take a look. That how can we actually improve that situation. This is the whole agenda of this module, right? When I call about bad code, then it can be anything. It can be an anti-pattern, it can be bad code namings, it can be bad styling, bad preparation of the classes, too much, I would say, cohesion going on. Multiple things will be there. Different situations we are going to go into, and I'll try to take as many real life examples as possible, right? In this module is not about algorithms. This is definitely not about algorithms, that you start implementing algorithms of different kind. No, it's about how you structure the code. One more outcome of this module is how do you structure your code, right? How readable your code becomes, right? How readable your code becomes, how maintainable your code becomes. This is one of the most important aspect, that how maintainable your code is, right? How extendable your code is, right? These are going to be the outcomes of this module, right? The outcome of this module is not to understand some algorithms, or outcome of this module is not to understand just some design patterns, but instead try to understand that what are the problems, what are the solutions, what are the different design patterns proposed, where can you use those design patterns, and so on. And eventually, we want to converge ourselves towards a position where we are able to write as better code as possible. So here on your screen, you can see that I have prepared one lesson one. Inside that, I have a user profile.js file. Okay. We don't need anything else. Let's close everything else. Okay. Now, there might be a case that you are able to understand this code. There might be a case that you are not able to understand this code. Anything can be the situation. Doesn't matter. It's a simple React code. I'll tell you what's happening. This function user profile, you can say that it is capable of building a UI component. You can see there is some HTML looking code. It's not actually HTML. This is called as JSX. But for the timing, you can assume that this is some HTML looking code. That means it is capable to actually build some UI. Okay. And then you can see there is some state management that is going on. And you can see there is some API calls that are going on. Few things are going on. Just go through this code. Now your task is just go through this code here, right? This code can be found on this link, on this GitHub repo. Go to LLD principal GitHub repo, go to source, go to lesson one, go to user profile.js. You can read this whole code here, or you can just pause yourself here and read this code here. Now, what I want to understand from you guys, I should say that what I want you guys to think is, what is not going well with this file? Okay. Is there any issue with this code? Is there an issue with this code, right? So if you know UI or React, then of course you'll be able to understand. Even if you don't know, then I've told you some basic things. You can pause yourself here. You can Google about what is state, what is use state. You can Google about what is JSX, whatever you want to Google about, you can Google. I just want you guys to think, if you see this piece of code, is there any problem with this particular file? So let's bring the code here. Let me bring the code here on my screen, and let's see what are the issues with this code. As I mentioned, we do not want to go into any algorithmic stuff. We don't care about algo here. Okay. Always keep this thing in mind. We do not care about any algorithm. We will care about what's going wrong with the code quality or the implementations. Okay. Cool. This code snippet is violating one very important design principle. I'll come to that. But let's see, first of all, what is the issue with this code. So this code actually represents a React component. Okay. React is a front-end single page application library. Component, you can say, is a reusable UI component. Let's say if you have a button and similar button you want to show somewhere else in the code, you can make a component out of it and directly reuse it. Okay. So this is a UI component user profile. Now, if you carefully see, this part of the code handles how the UI looks. Okay. This part of the code handles how the state management is going to be done. And this part of the code handles API calls, okay, or network calls. Now, this API calls are also impacting the state. You can see in the API calls, we are calling some set loading function, which was a part of the state. Okay. So they also impact the state and so on. Now, the thing is that in one line, if I have to explain what is going wrong with this code, then this function user profile is doing too much, is doing too many things. This function is actually doing too many things. What do I mean when I say too many things, right? What do I mean when I say too many things? Too many things means this component, or I would say this function, because technically to represent a component, we are writing a function. This function handles how the UI looks, how the UI state is going to work, how to have the API calls done, and how based on the state the UI changes as well. A lot of things you are doing directly here. And this violates a principle called as single responsibility principle. So there is a set of principles called as solid principles, right? We'll talk about solid principles in a moment. You can say the S in the solid stands for single responsibility principle that we are talking about here. Okay. So it's just that 5 design principles kept together makes the word solid. So that's what people call as solid principles. So one of the solid principles is single responsibility principle. Okay. Now, what do you mean when you say single? What do you mean when you say single response? What is the meaning of this word single? Single means that some work is done in isolation. Okay. That is, you are not doing two things. You are not doing something apart from one major task that has been allocated to you. Okay. This is the meaning of single here. This is the meaning of single here. And responsibility means the work that you are expected to do. Now you might be thinking, sir, what is the problem with doing this? If you see any YouTube tutorial, any courses, most of the people will actually do things in this way. And I'm not saying it's wrong. I'm not saying it's wrong. I'm definitely not saying it's wrong. It will show you the right output. If you see the UI perspective, it will most probably show you the correct output. And for beginner level or very small UI component, this still makes sense. But the problem is with this kind of a coding principle where your one function is handling too many things, the issue comes with two main parts: maintenance and extendability. Okay. What's the issue with maintenance? Now think about it. Let's say you want to introduce some more states, or you want to have some conditional API calls. The response of the API call you want to handle in a better way. The error handling you want to do in a better way. All of this is going to be clubbed inside this same function. And you are going to again and again keep on changing it. You are going to again and again keep on changing it. Can I say that? This is problematic here. This is actually problematic here, that you are, for too many reasons, you are going to change this module of the code, right? That's why we say that single responsibility principle is getting violated here. So if you want to detect, are we violating single responsibility principle? One of the biggest way, or one of the simplest way you can say, is to see that are there multiple reasons to change your function or class? Are there multiple reasons due to which some change can occur here? Let's say one reason we keep that if the UI has to change, I want a different UI altogether, then this function will change. If new API call I want to integrate, then this function will change. If state management has to be done, let's say now we have to do state management Redux, then this function needs to be changed. So there are too many reasons due to which this function can actually change, right? And that is actually problematic here. Now here we have one more example, and this is a Java class that I have written. Right, this is an employee class. You can see this employee class has a bunch of public methods. One of the public methods is to get the ID. One of the public method is to fetch the biodata of the corresponding employee. One of the method is to calculate salary, and one of the method is to print performance report. Right? Now, this class has a similar issue. And what is that issue? This class also violates single responsibility principle. And why does it violate single responsibility principle? Because again, there are multiple reasons to change this file, change the code of this file. Let's call out all the reasons. One of the reasons can be that in the employee class, you introduce new attributes. In the employee class, you introduce new attributes. If you are introducing new attributes, then probably you might want to have more getter setters. I just wrote one getter, but maybe you want to have more getter setters, right? That is one reason. That means the employee entity, the real life entity employee, if you want to introduce new attributes, one reason to change this class is going to be that. Apart from that, currently, there is a function calculate salary. Now just think about it. If the do you think calculate salary algorithm can change frequently? Yes, it can, right? The calculate salary algorithm can change. For example, if let's say there is currently at this point of time, there is old tax regime in India and a new tax regime in India, right? Now, based on what tax regime the employee opted for, the salary calculation is going to be different. Later, let's say the government of India introduced some third tax regime. Then you have to again add that logic inside this calculate salary method. Can I say that? Right. Or let's say you have given flexibility to the employee that they can actually adjust how much amount of provident fund is going to be deducted from their salary and how much amount of provident fund the same that company has to also put in. Then again, if you introduce, maybe initially you have the logic that this is a hard coded value that every time 12% of the salary you have to put in your PF and company will also put. But let's say later you introduce flexibility that not 12%, let's say government said that it can be less than 12% also. So you have given employees flexibility that now your PF is flexible. So there is a new algorithm that is going to compute everything. Then this function is going to change. That means calculate salary method have concrete reasons that the algorithm inside this is going to change, due to which we got one more reason to change the employee class. One reason was to introduce new attributes to define the entity employee. Another reason is for salary calculation. One more reason can be, now you see, print performance data. Now let's say at this point of time, this print performance data prints the performance report in a PDF format. Later you want to introduce a CSV format as well, right? Later you want to introduce a mailing criteria as well, that this should be mailed and so on. Again, this class has to be changed, right? Fetch biodata. Let's say at this point of time, fetch biodata is parsing your resume and fetching the data out of it. Later, let's say you are also going to fetch the biodata from LinkedIn of the employee. Then again, this class has to change. So can you see, there are more than one reasons to actually change the class. That means this is violating single responsibility principle as well, right? So what single responsibility principle eventually says that if you do not follow single responsibility principle, then the maintenance of your classes and functions and files is going to be very difficult. The reusability becomes very difficult. Now let's say if somebody has to implement their own set of calculate salary, right? Let's say calculate salary method is currently for full-time employees and currently for interns. Later, let's say you want to add a calculate salary method for vendors. Then you will be putting a lot of if else, right? You'll be putting a lot of if else. What kind of an if else? You'll be putting something like if this dot employee type is equals to an intern, then execute some logic. Else if this dot employee type is equals to vendor, or let's say FTE, then you execute some logic. And you can see a lot of if, else, if, else, if are going to come up, right? What will happen here? Your extendability, that how extensible your code is getting hampered. Your reusability is getting hampered. Maintenance. This code is very hard to maintain. Why? Because you have to write unit tests. You have to do testing of all of the codes, right? If testing becomes hard, maintenance becomes hard. Because at any point of time, if your unit test become too complex and you stop writing the unit test, or let's say it's very hard to write unit test for a particular piece of code, then it increases the chances that that code can break in production because you have not done testing fairly well, right? And there can be other classes. For example, there might be some other class that wants to calculate salary. A lot of classes are now going to start depending just on employee class because it is already handling too many it is already handling too many tasks, right? So all of these calls out for the issue inside the sharing of the responsibility, that why you should not share responsibility, right? This is what single responsibility principle calls out for. And same issue was there with this front end code as well. So my point being that doesn't matter, you are doing front end, you are doing back end, whatever type of domain you are actually working with, these design principles actually work everywhere, right? That's why it's very important for us to see where single responsibility principle is getting violated and how can we rectify it. Now, if I talk about how can we rectify this React piece of code, so let's start talking about it. Okay, let's start talking about it. I have prepared some bunch of pseudocodes, so I'll show it to you guys, and then you guys can tell me whether it makes sense or not. So I'll create a new folder, call it as example1 front end. Okay, and let's move this inside lesson1 refactor and move the user profile.js inside example frontend1. Okay, cool. Okay, so now you can see there is a user profile.js, and I'll create one more package here, call it as problematic code. This user profile.js is a problematic code. Okay, then I'll create one more package and call it as better code. Why I'm calling it a better code, I'll tell you that, because things work with respect to one second, let's delete it. Okay, and new package, let's call it as better code. Okay, inside better code, let's try to write how we can actually refactor this React.js code so that it becomes slightly better for us to handle. So currently, if you see the code, if you see the user profile.js code, okay, in this code, you can see there is state management, there is API calls, and there is UI management, everything happening in the same file. So React actually proposes something called as custom hooks. Okay, if you don't know about custom hooks, just go and read about it, no problem. But what you can actually do is you can have custom hooks implemented inside your code. And that you can actually use. For example, I'll create a new file. I'll call it as, let's say, use user fetcher.js. Okay, and here I'm going to just put a coding implementation. Okay, all this code is not going to run because of course the node modules and everything are not set up, right? But now you can see I have created a file called as use user fetcher, and you can see I've written a function. Let's see what that function does. Now this function is just responsible for two things: that how exactly you are setting the state, because after the API call you are making changes in the state, right? After the API call you are making changes in the state. So these two are tightly coupled. But what we have done is we have segregated it out in a new file altogether. You can say a new function altogether. Then you can make one more file, call it as, let's say, user profile UI.js. Okay, and let's say you just put your UI component here. You can see it takes a user and tries to write whatever UI has to be implemented for that user. It doesn't care about how the state is getting managed. It doesn't care about how API call is getting managed. Nothing. And then to club both of the use case, there will be a final component that we are going to build called as user container, right? And here, what we are going to do is we are going to use that use fetch user data, this method, use fetch user data method, right? And you can see directly we are just going to call our user profile. Now you can see state management is separately done here. API call is separately done here. How the UI looks is separately done here. And we have just clubbed both of them, right? Now, do you think if at any point of time, just the UI has to change, we'll just change it here. If at any point of time, the API call response and their state management is going to change, we are just going to change it here. If at any point of time, based on what state has changed, what UI needs to be shown, that has to change, that will only change inside the user profile container. And it makes all these three better testable as well, because we can write dedicated test of how exactly the API calls and everything are going on. In fact, we can have one more level of refactoring that this API call can because this might be a reusable API call, may or may not be. We can actually segregate it out in a separate API call folder where all the API calls are done, and then we just try to consume the response based on the promises, right? So this is kind of like a better way to actually handle stuff. If you see with respect to user profile.js, where everything was getting handled in the same file. This approach of segregating out your data based on responsibility makes the code more testable. Apart from that, just think about it. If in any other UI view, if you want to use the same user API call and you show the same user data, then also you can do it. If this component user profile, let's say you want to show it somewhere small in a very small dimension in some other screen, you can just directly show it if let's say you don't need any state management or anything. So the responsibilities now have been divided. And even if not just, let's say in front end, let's say for React, if you see a mobile development code as well, right? For example, when we write Flutter here in Google, we try to do the same thing, that all the state management related details goes separate. All the UI related details go separate. And in fact, for API calls and business logic, we have a dedicated service layer altogether. So we do divide our code into multiple layers so that we are able to understand, okay, what part is just getting handled with one piece of code and what other part is getting handled or delegated to some other piece of code. Now, we have this employee class that is definitely having some problematic code, right? Because there are multiple reasons to change this same class, and we definitely want to get out of it. We don't want to be in a situation where we have to change the same employee class again and again due to multiple reasons, right? So let's try to actually handle it. So I've refactored this bad employee class in problematic code, and this better code, I'm going to write a new employee class. Okay. Inside this employee class, what we are going to keep, we are just going to keep whatever are our basic set of variables, right? So let's say public employee int ID, okay, and let's say private final int employee ID. We say this dot employee ID is equals to ID, okay, and let's say we have a getter for this because ID generally doesn't get changed by the client. We just have a getter, not a setter. Okay. And we are going to return this dot employee ID. See, now this employee class is only responsible for the entity management of employee. How the employee looks like or what the employee structure actually does, that is the only responsibility of this employee class. If we have to change this employee class, the only reason for the change is going to be if the change in the entity structure of the employee class needs to be done. Then what we can do is we can have one more Java class, right? Employee salary calculator. Okay. It's a simple class. Right? And then we can say public double calculate salary. Okay. double calculate salary. For the timing, I'm just going to return 0. And what it does is it takes an employee instance. Okay. E. Right. And whatever employee you have passed, for that particular employee, it is going to calculate the salary. Right. Now, there is still some issue with this code. Technically, you can see now why you should change employee salary calculator. Why you are going to change employee salary calculator. At any point of time, if the logic for salary calculation changes, this file is going to be changed, right? So technically now this file and employee file are compliant to single responsibility principle. But at this point of time, this employee salary calculator can violate one more principle, but we are going to talk about that later. Currently, our agenda was to just solve the SRP issue, the single responsibility principle issue. That is definitely getting resolved here. Any salary calculation logic has to change. This file needs to change. Employee class file doesn't need to change at all. Right? Then similarly, what we can do is we can say fetch employee biodata. Okay. You can say public void fetch biodata, kind of like this function, right? And here as well, I am going to pass the employee instance. That is, for whatever employee you want to fetch the biodata, you can actually fetch the biodata for that employee. Okay. Right. Again, as I mentioned, this class again now follows single responsibility principle, because the only reason to change this class is when fetching of biodata logic changes. Although there can be a situation later that it might violate some other design principles, but we are going to come to that later. And so on. One more class. What was the third implementation that we wanted? The third implementation was to print performance data, right? So let's say we have a new Java class, performance evaluator, or you should say employee performance evaluator. Very simple. And you can say public void evaluate performance employee. Okay. And then some logic you have for performance evaluation and so on. Now you can see every file has its own use case for which any change needs to happen, right? And you can see very easily we have made our code compliant to single responsibility principle. Okay, so I'll push this code. Activity 2 solution. Git push. Here we go. Right. So I believe now you are getting an idea of what is actually going on here. So now we have a new code snippet in front of us. This is example 3. What this code snippet says that there is an employee performance generator class. It has a function string generate report. What it does, based on different type of report type, it generates employee performance. Does this class violate single responsibility principle? In my opinion, no. Why? What is the reason of change of this file? The only logical reason of change this file is some change in report generation. Now that report generation change can be a PDF, Word, anything. But the logical work of this file is what? The logical work of this file is to generate report. Some change in generate report happens, then you change this report, right? So in my opinion, this file definitely follows single responsibility principle. Of course, there is an issue that I was trying to call out here. When I talked about better code, performance evaluator and everything, then I already called it out that there can be a situation where this code can be problematic. This code is problematic because, let's say, currently you want a report type of PDF and Word. Later, you want to have a report type of Excel, then later CSV, right? So your class is going to undergo a lot of modifications, right? What SRP says, why do you want to change a class? I want to change a class for performance generation change. And that is the only thing that this class does. So SRP is getting followed. But there is another principle that talks about
maintenance of the classes, right? That this class is not, I would say, extendable. We have not made this as an extendable class, but instead we are modifying this class too much. That's a separate principle that is getting violated. That principle is called as a OCP, or open close principle. We'll talk about that separately. But as of now, in my opinion, this definitely follows SRP. Now, why I'm saying in my opinion? Why I'm saying in my opinion? If somebody doesn't know that SRP, OCP, everything separately exists, all these principles separately exist, they might feel that, okay, this is a bad code. I'm not saying it's not a bad code. This is definitely a very bad code. But on the scale of SRP, it's not. On the scale of SRP, if you judge with respect to SRP, it's good. Right? That's why we always say that design principles, clean code practices is with respect to some reference frame. If you never know the terms like SRP or OCP, but still you can actually identify there is a problem with this code, right? And you can refactor, think about how you can refactor it. That's a later task. So that is why always it is recommended that when you are writing code, try to take suggestions, because there might be multiple approaches to make your code better refactored, better clean, better readable, right? Generally, not just one solution is the only possible solution. Yes, we will learn design patterns. Patterns talk about some very specific use cases where that design pattern is the supreme most solution. But when you actually work in a real life use case, there might be a case that you are not able to apply 100% of a design pattern or 100% of a design principle. Maybe up till a certain degree only you can apply, because your use case doesn't allow 100% application of a particular principle, right? So always keep this thing in your mind. Do not be rigid. First thing. Second thing, do not over engineer. We just were talking about SRP. SRP is not violated. That's enough for us. The moment we go beyond SRP, that means that the problem that we were having in our hand, we are over engineering it. Nobody asked us to solve it beyond SRP. So we should first take a look at SRP and then only try to do something else once we are clear with the thought of SRP. So in my opinion, this class definitely follows single responsibility principle. Now this is one possible solution that might come to your mind, but there is an issue with this code. What is the issue? You can see there is a user manager class. Currently it's creating the user, deleting the user, and it is logging user activity. Now in this solution, what is the problem? Creation of a user and deletion of a user is kind of like user life cycle. There's something called as life cycle method, right? So it's a user life cycle. User life cycle is something of a common concern, right? So there is no point of segregating them into different files, because maybe let's say there is some common logic that you want to use. You will be able to delete a user if you have ever created it. That kind of logics you have to actually implement, right? If you have to create a user, then most probably you might have to access some repository. I'll talk about repository, what it is, but let's say you have to access some class that talks to the database for creation of a user and deletion of a user. Can I say for both of them you have to talk to a database? It's a user life cycle kind of a thing, right? So segregating them into two separate classes doesn't make a lot of sense. Okay. Now, what could be a good solution for it? Again, as I mentioned, like you can actually give a counter that no, we feel that create user, delete user is separate concern, though they should go separately. But I believe a fair solution here can be something like this. Better code dot let's say, okay, oh my bad. Here let's make a new Java class, user manager. Okay, and from our user manager, from here I'll bring these two coding pointers here. Okay, so now I have made a user manager class and kept create user and delete user in the same place, because this handles user creation and life cycle. If let's say I have to interact with some database, for example, let's say there is some class, this let's say I'm just giving a hypothetical situation. Okay, so let's say user repository. What is a repository class? Repository classes or repository layer is generally used for handling you can say DB interaction or data fetching interactions. Okay, user repo. And let's say here you do something like this dot user repo dot create. Okay, so we have a create method, right? And let's say this dot user repo dot destroy method. Okay, something like this, and then it takes a bunch of arguments, whatever you want to pass, it takes a bunch of arguments. Okay, you can see something of a common concern, right? It's something of a common concern, right? But logging user activity. Now the thing is that creation of a user and deletion of a user most probably will be affecting the same table of a common database. Like user table must be present in some database. But activity logging may or may not be in the same database and definitely not in the same table. We are never going to store user activity in the same table where we are going to store the details of a user. So what you can actually do is you can have a separate class activity logger, and you can log activity of multiple situations, right? One of the activity logging that we are going to do is public void log user activity, and let's say we are going to pass, let's say, some username, something like this. Okay, if you want to log something else, that logging logic can also go here, right? So, and let's say this is going to interact with some other database altogether. Let's say because logging the activity that you have, like whatever activity your user is doing on your app, that is generally not going to be related to any relational context. So most probably you'll be having a no SQL kind of a database. So it might connect to a separate database altogether, right? So you can see proper responsibility segregation we have actually done, right? And that calls out for a fair implementation for a single responsibility principle. But again, as I always say, when you are actually designing code, some people can still say there are still more issues, right? There are still more issues. Or let's say I feel that create user, delete user, or everything can go in a separate file. If you start putting everything in a separate file and a separate function, then there will be, for every small thing, there will be a new file and new function. That's not how things should work, because the more classes you will load, the more load time is going to increase for the initiation of your build, right? There are concerns accordingly, right? So always make sure that you have to put a thin line between when have you over engineered and when have you just did the correct amount of refactoring and engineering, right? At any point of time, if you start over engineering, that's problematic, because then there will be a lot of files to debug, a lot of files to actually manage, build time increases, a lot of things can happen. But if you do too less, then it will be not maintainable, not extendable, right? Writing unit test is going to be super hard, and multiple things, right? So moral of the story is that always make sure that each and every file has only one reason to change, right? Now, these are some very specific situations, but you might ask me a question that how do we know, one second, how to detect that SRP is not fulfilled? How to detect if SRP is not fulfilled? Okay. One case where most probably SRP will not be fulfilling is monster functions. I'm not sure if you have heard about the term monster function. It's just a fancy term to say that a very big function doing a lot of things. For example, if you see people writing Node.js based backend, right? And let's say the framework that you use Express, or let's say in Java, let's say they are use Macronaut or some other micro framework like Python Flask. Then what generally people try to do is in the controller layer, they try to write all of the logic. That is, they try to write how request response is handled. They try to write DB interaction. They try to write business logic, everything in the same controller function. This leads to a very big function altogether, making it a monster function. So generally, whenever you see a monster function, that things that could have been separately handled, that have no relation until apart from just passing data here and there, are getting handled in the same function, then that's probably a monster function that you guys can actually understand. For example, if I create one more package, example 5, and I show you a monster function. This should not be a class. I'll just need to make a normal file. Monster.js. Okay, so let me bring you a code in front of you. Bring a code in front of you. Okay, so let's copy, paste. Okay, this is a JavaScript code with a Node.js kind of a backend. You don't need to worry about how the code is and everything is working. But if you carefully see, this is a controller method. This is a controller method. In this controller method, what's happening? You are handling request and response, the HTTP request and HTTP response object. You are trying to handle DB interaction. Apart from that, business logic, that what algorithm you are using for hashing the password, that logic, everything is getting handled here. How the response should be sent, everything is getting handled here, right? This is an example of a very simple application, but the moment your application grows to a scale of things like Paytm, Zomato and everything, this can be quite humongous. And this, you can say, is a seed of a monster function, right? What could have been a better way to handle the same thing? The better way to handle the same thing could have been something like this. So for example, let's say currently you can see there is a lot of folders and everything. It's a Node.js project. If you carefully see, then there is a routing layer that I have prepared. Inside this routing layer, you can see there is dedicated routes for every resource. You go to a route, then you map yourself to a controller. In the controller, the only responsibility of a controller is to take the request and give the response. That's it. And you can see that's the only thing that is happening. For any business logic purpose, we are passing the call to a service layer. We are passing the call to a service layer. But still, service layer has the only reason to do business logic. So for any DB interaction, we are passing the call to repository layer and so on. So you can see properly segregated files with every file just handling one thing and having one reason to get changed. For example, if my repository has to change, I'll talk about repository pattern. If my repository has to change, the only reason is going to be some new DB interaction or some new query that we have to implement. That's it. So I hope you got the point of monster functions, right? Another, I would say, way to detect is that commons/util folders. A lot of time, what happens is that thinking about reusability, you try to put a lot of things inside util folders and common folders, right? Because you feel that, okay, this is a utility library method. Let's put it in a separate util folder. But there, if you have not done proper file segregation, proper class segregation, then it can lead to a problematic situation again. Because then, let's say you are having some common functions of date time operation. Apart from that, you are having some common functions of random number generation. If you put all of them in same class, calling it as a util class, which is also handling date time related functions and also handling random number related functions, then again, it's a problematic scenario. Apart from that, third, too much if else. If you see too much if else, and with every if else, technically you're doing something else, right? They are not related with each other. Then also there might be a case that SRP is getting violated, right? I would like to show you a very good example of SRP, that where SRP is getting followed, right? So if you have done coding with C++ at any point of time or Java, then you must be aware about the Java util library and the C++ STL library. So if you go to C++ STL, okay, and you go here, then when you start reading the docs, you can see there is a separate class that actually just handles how arrays will work, how deck will work, how a forward list iterator will work, how if any map related changes are there, just map, unordered map, separate, unordered map. You can see proper logical segregation. Every file has only one reason to change, right? Similarly, you will see Java util as well. If you go to the util package, then inside the util package, you will find separate implementation for linked list, tags, everything that you want to find, right? Hash maps, right? Hash tables, whatever you are looking for, right? So I believe these internal libraries are very good examples where single responsibility principle is getting followed.